So here is our final problem number 3, where we have two objects with different masses and different velocities colliding in a perfect elastic collision. And the second scenario is what happens if they are in a perfect inelastic collision. Okay, we have their masses given and we have their velocities. Remember that the velocity is so positive axis that way. So we have two objects moving against each other. Okay, we are going to find the velocities for elastic and inelastic collision. So inelastic is pretty simple. We're going to do it regardless. But let's start with elastic collision. So recall that in elastic collision, momentum is conserved, right? And kinetic energies of the system is conserved. So the first one is pretty straightforward, the equation. Second one is, if you recall, we derive the conservation of relative velocity. So it's pretty much, this is conservation of kinetic energy in a simplified form. So we have two equations, or two unknowns, v prime 1 and v prime, v2 prime and v1 prime. So we're going to use elimination. So we can multiply this by m1, for example, to eliminate v1 prime, so we can solve for v2 prime. So we're going to multiply the whole equation by m1. Okay, and if I add them up, what's going to happen is that these two will cancel out. Okay, and then we have 2 m1 v1 plus m2 minus m1 v2 is equal to m2 plus m1 times v2 prime. All right, and we solve for v2 prime to be 2m1 over m2 plus m1 times v1 plus m2 minus m1 over m2 plus m1 times v2. Okay, so this is the equation for finding v2 prime. So at this point, you can plug in the numbers. Remember that v1 and v2 are vectors, so make sure we use the sign for direction. So if we do the same thing, okay, but now we multiply the equation number 2 by m2 to get rid of v2 prime, we're going to get v1 prime, and guess what's going to happen is going to be m2 minus m1 over m2 plus m1. So it's going to be pretty much similar substitution elimination, but the coefficients will be reversed. All right, m2 plus m1 times v2, and this is going to be the equation to find v2 prime. And again, careful with the sign for the vectors. Okay, now for elastic collision, it's pretty straightforward. We have m1 v1 prime plus m1, let's write it again, m1 v1 plus m2 v2, recall that these are vectors, is equal to, since it is an elastic collision and it gets stuck together, is m1 plus m2 times v prime. Okay, and we solve for v prime, which is m1 v1 plus m2 v2 divided by m1 plus m2, and that's how you find the final velocity, or the velocity of a system after inelastic collision. And again, careful with velocities, right? Because they are vectors and you have to make sure you take care of the signs. Okay,